Welcome back to a new video. In this video we are going to do a data science project. We are going to do data analysis, feature engineering. We will train machine learning models and we are going to create a FastAPI app with a prediction endpoint. The dataset is going to be about the loans and we are going to try to predict the loan status. I'm going to add the datasets link in the description of this video. Let's start coding. So now we are at my code editor. It's VS Code. You can use others like PyCharm or Colab notebooks, whatever you want. What I'm going to do is I'm going to create a notebook right now. Here's the data file that we are going to use. Again, I'm going to add this in the description of this video. You can download this file from the description. It's a Kaggle link and it's free to use. Okay, what I'm going to do is I'm going to create a file with the name notebook.ipynb. I'm going to go by cell and then I'm going to create the API app. We are going to use FastAPI for that part. Firstly, we are going to use Jupyter Notebooks, the IPynb expansion ones, for analyzing the data and modeling, creating the machine learning models. Great. At the first step, what we are going to do is I'm going to start by importing the pandas. And then I'm going to say data is going to be, actually let's set it as data frame pd read csv, and we are going to give the name in here. I'm just going to copy that and then I'm going to paste it in here. Then we can check if it's correctly uploaded, like dataframe.head, which is going to display the first 5 rows of the data set. When I code this, we can see it seems like okay. Great. So we have the data of loans, like there is loan ID, gender, married, dependents. It's different for each individual, and education, self-employed, applicant income, co-applicant income, loan amount term, credit history, property area, and loan status. This is going to be target for our machine learning models to predict, like if it's N, then loan is not approved, and if it's yes, it means that loan is approved. And also let's check other ones like credit history in here, loan amount term. I guess it's about months. Like let me go to the tail, maybe we can see different values in here. Yeah, it's maybe day wise, I'm not sure. I think it's day wise. And we have the loan amount in here. Then we have applicant income. So we have a lot of values, like we have the education data, self-employed, dependent data, married, gender, and we are going to create a model with these features. Firstly, we are going to analyze and we are going to do some visualizations, then we are going to model, and at the end we are going to turn this into an API, like it's going to be able to give response to the calls from different places, like they are going to give the features to our model, then they are going to get the no and yes answer from our model. Like it can be from a mobile app or it can be from a web screen, it can be anything. It can be inside an embedded system. So we are going to turn this machine learning model into something that people can take responses from outside the server. Okay, so at the next step, what I'm going to do is I'm going to call dataframe.information for checking the general data type and information like memory usage in here. We have floats, integers, and objects. We have the columns and non-null counts. So if you see different values in here, it means that there is null values in your data set. We are going to clean them, of course, but it's just a small tip. What we can do right now is I'm going to say data frame is NA, and if you call this like that, it's going to return booleans, as you can see. But if you add .sum after this, you are going to see that you are going to get the null counts column wise. So what I'm going to do is I'm going to clean all the NA values, like I will say data frame drop NA, and I will set in place equals to true. So what this do is if I run it like this, it's going to give me a new data frame and it's going to be non-null ones. Like you can just check .info and you are going to see that there's no different values in here. Also you can just check the new data frame like is NA and sum. You will see it's going to be 0. But if you don't just apply, you can both assign it like this or you can use in place. If you don't do that, at the original data frame, you are going to see that you are going to still have the null values. So what I'm going to do is I'm going to clean all of them, and then I'm going to add in place equals to true like this. And what I'm going to do right now is I'm just going to call data frame is NA sum again, and we are going to see that we are not going to have any NA values. Great. Okay, now let's check if we have any duplicated rows or not. So again, I'm going to say data frame duplicated. And if I call it like that, it's going to return me booleans. So what I'm going to do is I'm going to add sum at the end. So we are going to see if we have any. So we have no duplicated rows in our data set. Great. Okay, let's call the columns we have. And then let's start to creating data visualizations and some group bys and analyzing our data. So what I'm going to do right now is I'm checking the columns, and here I'm going to start by creating a histogram of the applicant income so we can have a general overview of the incomes. So for that, what I'm going to do is I'm going to say cborn.histogram plot data frame applicant income in here, and then I'm going to say the KDA as true, and then I'm going to say PLT the title, and I will say histogram of applicant income. So I just realized that I didn't imported these libraries. So at the first place I will say import cborn as SNS, import matplotlib.pyplot as PLT, and let's also import numpy, maybe we use, maybe not, import numpy as MP. Great. So right now we can continue. You can see the cover changed on the library usages. Great. At the next step I will say plt.xlabel, and it's going to be applicant income. Also let me correct the typo, and ylabel is going to be frequency. And then at the last step I will say plt.show like this. Here it is. Okay, let's create a count plot of the loan status. So I'm going to say cborn.countPlot, and I will say count plot x is going to be loan status, and data is going to be data frame. Let me check real quick the column name, data frame columns. It's loan status. Okay, I wrote it correctly. And then I'm going to say title is going to be loan status in here, and X label is going to be loan approved, and Y label is going to be count, and I will use plt.show at the end. Let me quickly show what happens if I don't use plt.show in Jupyter Notebooks. You can see that it printed a text, but when I do this, it's not going to print that text. Okay, as we can see, most of the loans are approved. So yes is more than the no. Okay, so let's make a group by. Let's find the average loan amount by education. So for that, I'm going to create something like average loan amount by education. And it's going to be data frame group by education by loan amount. That mean. So if I do like this, let me quickly show you what happens. I'm going to do this in here. It's going to return me a pandas series. So you can easily manipulate them, like you can say sort values, and you can set ascending as false for changing the order, or true. You're going to see that it's going to change, or you can just say head 1 for only taking one entry from here. You can do anything you want. What I'm going to do in here is I want it as a pandas data frame, since I'm going to create a visualization with that. So I'm going to add reset index. So it's going to return a data frame instead of a series. So I'm just going to take this reset index, and I'm also going to apply that in here. The codes are the same. And in the average loan amount by education, you are going to see that we have this data frame in here. So now I'm going to create a bar plot like SNS bar plot, and X is going to be education and Y is going to be loan amount. and data is going to be average loan amount by education. Then I'm going to give it a title like average loan amount by education, and X label is going to be education, and Y label is going to be average loan amount, and I will say plt.show at the end of this. So here it is. Most of the values, actually we can say most, maybe there's no big difference. We have more graduate than not graduate. Okay, great. So let's create a box plot of loan amount by property area. So for that I will say cborn.boxplot. X is going to be property area. Let me quickly check if I wrote it correctly. The column name, data frame columns. Yes, I think it's true. Yeah. Okay, Y is going to be loan amount, and data is going to be data frame, and title is going to be loan amount distribution. And then I'm going to say X label is going to be property area, and Y label is going to be loan amount, and I will use plt.show at the end. Also we can give it a title, more descriptive one, like by property area. Great, so let's check how it looks. Great, so let's continue with the count plot of loan status by gender. So for that what I'm going to do is I'm going to say cborn.countplot, and X is going to be loan status. I'm pretty sure I wrote it like that before, and Y is going to be, actually let me quickly change the X, it's not going to be Z, and it's not going to be Y in here, we are going to add hue this time, and it's going to be gender, and data is going to be data frame, and we are going to give it a title like loan status by gender, and X label is going to be loan approved, and Y label is going to be count, and we will use plt.show at the end of this. So as we can see, we have more males in our dataset in the distribution. Let's quickly check it too. So I'm going to take the gender, and I'm going to take the value counts like this. Also what you can do is you can just add parentheses and you can get the numbers. So we have mostly male, and if you want to create a plot from this information, you can just say that plot, and you can say kind pie, and then we are going to have a pie chart, male, female, and as you can see there is a Y label count that we don't want, so you can just do plt.ylabel, and you can give it an empty label like this, and you can use plt.show for disappearing this text, and now it needs to work smoothly. Great. So after this what we are going to do is let's create a count of loan status by merit status. So for that I'm going to say loan status by merit, and it's going to be data frame group by merit, and we are going to take the values of loan status like this, and then I will say value counts, and I will say unstack like this. And after that what I'm going to do is I will say loan status by merit.plot, kind is going to be bar, and stacked is going to be true, and then I'm going to give it a title like, let's say loan status by marital status, and I'm going to give it an X label like merit, and Y label like count, and I'm going to give it a legend with a title loan status, and also we can add X text like this, and rotation 0, and we can use plt.show at the end of this. Great. Also you can add grid if you have a numerical analysis. Let me quickly show you. If you add grid, you can see the background is going to be changed, but in this type of plot we don't need that, so we have our information in here. Great. So also if you just delete the title in here from the legend, it's going to still show the legend, without the title. So I generally use it with title, but this is also an option. Great. So now let's continue with creating a scatter plot of applicant income versus loan amount. We will say cborn.scatterplot. X is going to be applicant income and Y is going to be loan amount. And then we are going to set the data as data frame. So we can give it a title now like applicant income versus loan amount. And we can use an X label like applicant income and Y label loan amount. And we will use plt.show at the end of this. Great. Let's create a heat map to visualize the correlation between the numeric columns. So for that we are going to say numeric data frame, and it's going to be data frame select data types, and we will say include integer and float like this. And after that we can just check our numeric data frame. We can see we have our numeric features in here. What I'm going to do is I'm going to set something like correlation matrix, and it's going to be numeric data frame dot correlation, just like that. So when I call the correlation matrix, we can see the correlations in here. So I want to create a heat map with this. For that, what I'm going to do is I will say cborn.heatmap correlation matrix, and I'm going to set the anode as true, and I will say color map is going to be cool warm, like this. Here we can see that. So let's give it a title like correlation heat map, and also use plt.show. And now it looks better. Great. So our numeric features are not that correlated as I can see. Okay. Let's create a final plot and then move to the modeling side. So let's call the columns again. Actually, I'm not going to use these two. And let's group by self-employed since we didn't do anything with that. And we are going to take the values of loan amount average. So I will say average loan amount term by employed. Actually, let's correct this like, let's say average loan term by employed. That's what we are going to do. I will say data frame group by self-employed, and I will say loan amount term dot mean, and I want the data frame, so I will say reset index like this. And there's an error here, self-employed. So let me correct how it's written in the column name. Yeah, I need an underscore in here, and then it's going to work smoothly. And whenever we call the average loan term by employed, we are going to get this. Okay, so what I'm going to do right now is I'm going to say cborn.barplot, and X is going to be self-employed and Y is going to be loan amount term. Also I need equal sign in here like this, and then I'm going to set my data like average loan term by employed. Also I need quotes in here, and now everything is smooth. Okay, so next I will say plt title average loan term by self-employment, and then I will say X label self-employed and Y label average loan term, and I will use plt.show at the end of this. Great. Okay, so we can say that average loan term is more for the non-self-employed ones. Okay, let's get to the modeling side. I'm going to call the data frame again for selecting the variables that I'm going to use for predicting the loan status, and I think they are going to be, let's keep it writing. So X is going to be the variables that I'm going to use, of course applicant income, and we can let's not take education in here. Let's take married, and let's take like what we can take, not dependents, applicant income for sure, it's important. And let's also take education. Okay, education can be one. And I'm checking another ones. Loan amount is also important, I guess, so I'm going to take that amount. And I guess this 4 is going to be enough. Maybe we can also include credit history. Like, let me check the unique values in here. Data frame credit history dot unique, like this. And we are going to see that we have 1 and 0. So credit history is for sure a thing when you are applying to the loans, but I'm not sure. Okay, also let's also include it. So I will say credit history. Great. So from now on we are going to continue with X like this. And also let's set Y, our target variable. It's going to be the loan status. I'm just going to copy this from here and paste it in here. Great. So we have our Y ready too. So at the first place, let's start with Y. We are going to import the preprocessing, and we are going to use label encoder for change this text features to numeric ones. Like there's going to be 1 or 0 for N, 1 or 0 for Y. So for that I will say from scikit-learn import preprocessing, and then I will say label encoder is going to be preprocessing.label encoder. And after this initialization, what I'm going to do is I'm going to say data Y loan status is going to be label encoder dot fit transform and Y loan status. After this, if we call Y, we are going to see 1 and 0. So how we are going to understand if the 0 is N or 1 is N? There's two ways. The first one is you can just check the first indexes, like the first index in here is 0, and in here the first index is N. The second index in here is Y, and the second index in here is 1. So Y is 1, you can understand like this. Y is 1, N is 0. This is an option, but also what you can do is you can just call label encoder and you can use classes like this. And you're going to see that the 0 value is at the first place N and the 1 value at the second place Y. Great. Now we are going to do the same operation for the X, the text ones. Like we are going to do that for this, also do that for this. Also we need to get rid of the dots in here. So let's firstly start with the credit history. I'm just going to quickly check like credit history, and I will say let's see the first value of it. So it's, I guess it's float, not sure, quickly checking. So yeah, it's float, so we don't need to change that. Great. So credit history is cool, numeric. So what we are going to do is at the first place we are going to do that for the married label encoder fit transform, and we will say X married like that. And I'm just going to call the X again. You will see there's values 1 and 0. Remember the way that we used the label encoder dot classes, and we can see no 0, yes is 1. Great. So we are going to just repeat the same operation for the education. So we will say education, X education is going to be label encoder fit transform X education. So now I guess our data is cool. Okay, so the next step is going to be scaling our data. So for that, at the first place, before we are doing that, I'm going to tell why we are doing that. So in here we have values like 1 and 0, in here 0, 1, we have 128, and in here we have like thousands. So they are going to affect the model differently. That's why we are scaling, because we don't want this feature to dominate the entire effect. So for that, what I'm going to do is, I will say from scikit-learn the preprocessing import standard scalar. Also you can reach it from here, like let me quickly show. Here's the import. Preprocessing.standard scalar would also work, but I'm going to do like this for this to be more clear. I will say standard scalar, and then what I'm going to do is I will say x is going to be scalar fit transform x. So after that you are going to see that we have different type of values, like all scaled between 0 and I guess something like 3, 5, 10, whatever, but we have way lower values in here. Great. So the next step is going to be exporting this scalar, since we are going to use that in our FastAPI 2. So I will import joblib, and then I will say joblib.dump, and I will say scalar, and I'm going to set it like scalar.pickle. So you can see the scalar.pickle file in here. It's stored in here. We are going to use that in our FastAPI app. So let's continue. At the next place, we are going to use the train test split for evaluating our model performances. Like, for a quick recap, we are going to train our models with the training set, and we are going to test how our model are performing in the unseen data with the test set. So we are going to use both of them for different operations. So for that I will say from scikit-learn.model selection import train test split, and then I'm going to set features like xtrain, xtest, ytrain, ytest, and we will say train test split xy. Also we are going to set something like test size. It's going to be the percentage of the data that are going to be in the test set. So if you just write 0.2, the 20% of the data is going to be in the test set, and 80% of the data is going to be in the training set. So I will say test size is going to be 0.2. Great. So the next step is going to be defining a function for getting the model results. So with that, we don't need to rewrite all of that stuff again and again. So I will say from scikit-learn.matrix import, I'm only going to use the accuracy score in here, and I will say define model results. Actually, let's set it like model performance, and we will pass the predictions that we take from our model in here. I will say print accuracy score in model is, and then I will use that format. I will say accuracy score, ytest, and predictions. Great. So now we can start the modeling. I'm going to import the grid search firstly. Model selection, import grid search. It's going to be helping us in the parameter tuning side, but we are going to start with logistic regression, and we don't need grid search in there. I'm going to say from scikit-learn.linear model import logistic regression, and then I will say logistic model is going to be, I'm going to initialize it like logistic regression, and then I will say logistic model.fit. I'm going to give the xtrain and ytrain like this, and after training our model we can check its performance. Also you can say ytrain.ravel for not getting this error. It's not crucial actually, that values.ravel like this. It's not crucial, it's not going to give error like this. These both can be used, like if you just remove it, you're going to see that it's still going to work. Like I'm just going to make it pass, and then what I'm going to do is I'm going to say like logistic model predict, and I will give the xtest in here, and also we can get predictions with our xtrain. So with these features you're going to see that we get these values as predictions. Okay, great. After that, what I'm going to do is I'm going to store them in something like logistic predictions, and then I'm going to take the accuracy score by calling the model performance. Model performance, and I will pass the predictions in here. Logistic predictions, and accuracy score is 0.77. Actually, it's a good score, but it changes case to case. Like sometimes 0.5 can be good, sometimes 0.9 can be bad. Okay, let's continue. We are going to continue with the k-neighbors classifier. So for that, I will say from scikit-learn neighbors import k-neighbors classifier, and then we are going to define a dictionary with the possible parameters like parameters grid, and we will say number of neighbors can take values like 3, 5, 7. Actually, I'm not going to give out of parameters. You can just extend this list as you wish. Like you can just change the values. You can add 9, 1, etc. I'm going to give weight 2 as possible parameters, and it can be uniform and distance. Actually, I need to give it in a string. Okay. After that, I'm going to say grid k-neighbors, grid search cross-validation. I'm going to initialize it like k-neighbors classifier. Then I will say parameters grid, like this. After that, I will say grid k-neighbors.fit x-train and y-train. Okay. Again, if you don't want to take these errors, what you can do is you can just come to here and you can say values.ravel, and if you do that, you are not going to get error. I'm not sure if I'm going to do that in the entire video. Maybe I can, maybe I'm not going to. I'm not sure, but both way works, so no worries. You can just use this if you get an error like one-dimensional error. And after training our model, what I'm going to do is actually I'm firstly going to show you how you can get the best parameters. Since it's first parameter tuning in this video, you can just call the grid k-neighbors and you can say for the best parameters like this. So the neighbors was 7 and weights uniform. So if you want to reach to better models, you can just change this value to 9 since it picked the highest in this list, and you can just try it, like you can retrain and it picked 7 again. So you can just try 8 and you can just try 6 and see if it's going to pick the 7 again. Yes, 7 is the best performing one. Okay, but this is the way how you can find the best parameters. You can just extend this list as you wish. And next, what I'm going to do is I'm going to say, like, I'm going to make predictions with this. For that, I will say k-neighbors predictions is going to be grid k-neighbors.predict x-test, and after that I will call the model performance and I will take km predictions like this. It's 0.77 again. Okay, let's continue. So we are going to continue with the support vector classifier. For that, I will say from scikit-learn.support vector machines import support vector classifier. Then I'm going to initialize the model like this, and I will say parameters grid svr svc is going to be c. It can take values like 0.01, 0.1, and let's say 0.5. We can give it kernels like linear, RBF, and polynomial like this. After that, I will say grid svr svc is going to be grid search cross validation svm support vector machines and parameter grid support vector classifier. After that, I'm just going to train this like using grid svc that fit x-train and y-train. So if you don't want errors, you can just do that values, and then you can say Ravel again. So after that, I'm going to make predictions with it, like pred svc is going to be grid svc.predict scaled x test, and I will say model performance pred svc. So actually we didn't use it like scaled x test, so I'm just going to use x test, and accuracy score is the same with others, 0.77. I think 3 models are enough. Maybe we can try other models too, but surprisingly these 3 performed like same, and we can just change its performance, I guess, with simple improvements on the C side. So let me quickly check grid svc, the best parameters like this, and I think we are going to get 0.01. So we can extend this list in here, like let's say 0.05, and we can add 0.001 in here, and let's see what's going to be the best parameters right now if we train it like this. Like I'm going to make it run it again, selected 0.01, and the performance is going to be same, of course. Okay, so we can try 0.02 and 0.03. So let's try it like this, and let's see if it's going to pick the actual value again. It now selected the 0.03, so I'm sure the accuracy score is going to change right now. Actually it didn't, since it predicted the true labels again. Maybe we can try to improve it. So I'm going to say 0.04 is added right now. So 0.04 is selected, and it's still the same. So maybe it's on the testing side. We can change the percentage of the test set for getting different values. Like I'm going to make it 0.3. Then I'm going to restart the kernel, and we are going to have a different training and testing set, and I made run all, and let's see our values right now. Accuracy score on the logistic side is 0.84 right now, and on the kneighbor side it's 0.82, and support vector side it's 0.84. So let's continue with the support vector model. So with this model, what I'm going to do is I'm going to export it using joblib again. So I'm going to say, like, again, you can use import joblib. We already imported it. So I will say joblib dump, and I will say grid svc is our model. Then I'm going to give the name like model.pickle. So after saving this, you can see this pickle file in here, model.pickle. And I'm going to get to the X selecting side for seeing what we are going to take as the X. Also, we can directly call from here. Maybe, not sure. No, we only have array. So I'm going to married, applicant income, education, loan amount, credit history. So what I'm going to do is the first X is going to be 1 or 0 type of value, so it's going to be integer. We are going to take numeric values for all of them. Okay, cool. So let's create an example entry in our head, so maybe we can try that. So merit can be 0, applicant income can be 3,500, education can be 1, loan amount can be like 100, and credit history can be 1. So I'm just adding this to my notes, and I'm going to try this with the API we created. So after we have model.pickle and scalar.pickle, I'm going to create a file with the name app.py, and I'm going to create my API in here. So our values in here, and I'm just going to come to here for showing you how we can use the joblib. Like in here, what I'm going to say is, let's say we don't have anything and we are starting from 0 with model.pickle. So I will say import joblib, then test model is going to be joblib.load, and I will use model.pickle in here. After that, I can use this test model with predict, and let me get the values we just pasted, and we can give this values like 0. Actually, we need to scale them. I'm going to do that in the FastAPI app. For just showing you, I'm doing something like this, and we get the prediction. Like our prediction is 1. Loan status is going to be yes. So you can just use .0 like this and 1 in here. Okay, that's what we are going to do in the FastAPI side. So let's get started to coding our API. So let's start by doing the imports, like from FastAPI, import FastAPI, and then from Pydantic, it's going to be for defining the data types, import base model, and then we will say import joblib. We will say import numpy as MP. Then we will say class input data, and we will use the base model from Pydantic in here. Base model. We will say x1. Actually, all of them are going to be float like this. x2, x3, x4, and x5 like this. They are all going to be floats like this. Like, I'm just going to make copy paste for all of them. Yeah, it seems clear. Okay, now we are going to load our scalar and model. For the scalar side, I will say scalar is going to be joblib.load. Let me quickly check its name. Scalar.pickle. Scalar.pickle. And for the model side, we will say joblib.load. Model.pickle. Great. And then we are going to initialize the FastAPI. Like app is going to be FastAPI like this. Okay. Now what I'm going to do is I'm going to say app.post. We are going to define the endpoint with like predict, and our endpoint is going to be returning the prediction from our model. So I will say like define predict input data is going to be input data in here. Actually, I wrote date in here. It's going to be data. So we are using this, and I'm going to do like we are going to convert into numpy array our inputs. So I will say x values numpy.array. It's going to be 2-dimensional like this. Input data dot x1, input data dot x2, input data dot x3, input data x4, and we will do the same for the x5 like this. Okay, everything seems cool. Next, what we are going to do is inside this function we are going to scale our x values. So I'm going to say scaled x values is going to be scalar the transform x values like this. And at the final step we are going to use our model to make a prediction. I will say prediction is going to be model.predict scaled x values. So we are going to return prediction, and prediction is going to be prediction the first element, the value inside the array. And then what we are going to say is we will say if name equals to main, we will say unicorn.run app host. It's going to be hosting locally, and we are going to give the port 8000. Also, let's import the unicorn inside, like import unicorn, and our API is ready. So let's firstly test it, and after that I'm going to go on this line by line. Firstly, I'm going to save my file. Then we need to make small changes to our code, like I need to use this instead of equal sign because it's going to give us error. And what I'm going to do is I'm not going to give the prediction like this. What I'm going to do is I will just delete this. Then I'm going to set the prediction like integer, and I will pick the prediction 0 like this, and I will return a dictionary like prediction is going to be prediction. So after that, I'm going to save my file like this, and it's going to be the final code. So we change this and we change this part, and after saving this too, what I'm going to do is I am going to go to my terminal and I will say unicorn app reload, and I'm going to re-record on my browser on this address. You need to go to this address to your local host, and then let's meet on there in a second. So I'm at the screen, it says detail not found. Okay, we are going to go to the documents, and at the document side we can see the predict endpoint in here. So we can see the schemas in here and default. I'm going to just open this predict side and we can see the responses, and let's try our API to see if it's working. So let's firstly not change any values and say execute, and let's see what's going to be the response. It says 200. 200 means API is successfully working and giving responses, and our prediction from this values is 0. So let's change up these values. So let's say, like, I'm not remembering the exact values, but I'm going to try to remember. Let's say 1, 300, 3000 actually, and let's say 0, and then let's say 150. I guess it was the loan amount, and let's leave this as 1. It was credit score, credit history, I'm sorry. So I said execute, and our prediction is 1. So it means that the loan is going to be approved according to our model. So we can change these values and get different predictions for different values. And let's try to get to 0. So let's increase the loan amount if I'm remembering it correctly, and let's make credit history 0. So let's see if we're going to get to 0. Yeah, we get. Okay, we get the 0 in here, and we can see our previous responses too, and there is code and details side in here. Also, let's see what we have in here. Okay, so the request URL is in here. So if you're hosting this, then the users, if you're hosting this on your local system or on your company's system, then the users can reach to this API from this endpoint. Like, they're going to send an API request to this endpoint with the values like this, and they're going to get the output from the model. Great, everything seems perfect. So let's think of how this can be useful. Let's think that you are working on a bank and you are talking with customers and you are just viewing the customers' features, the values like credit history, for example, or income, and you are going to tell to your customer, like, you can take this loan or not. You can directly pass these values from a screen to our model that we developed, and you can tell the output to the user. Like, let's say these are the values from the user, the bank customer, and a bank worker entered to their screen, and the UI led model to get the prediction and get the value back. So at the backend side, the software engineer made an API request to your machine learning model and got the output. So output, let's see, it's 0. So the bank worker is going to tell the bank customer, that the loan is not approvable. Maybe you can just try to decrease the loan amount. Like, if you take the loan amount 100, it's still 0, but you can try to build a credit history. Like, you can just build a credit history, and then you are going to be able to take the loan. So this can be used like this. Let's get back to the VS Code for summarizing what we did. So I'm just going to close the terminal, and what we did is, at the notebook side, we started with analyzing our data, then we did feature engineering, then we developed machine learning models, then we exported them with also scalar. So we exported the scalar and the machine learning model, and on the API side, what we did is we imported FastAPI base model from Pydantic, joblib, numpy, UV code. Then we defined a class input data, 5 data is going to be taken in the format of float. Then we save the scalar and model. Then we initialize the FastAPI app. Then we defined an API endpoint as predict. Then in the predict side, we take our values in a NumPy array that our model can make predictions on. Then we scaled them with our scalar. We didn't do fit transform. We only used transform because we fitted it before. Then we take the prediction from our model by the predict method, and then we turn the prediction into integer, and we return the prediction like this, and we made our app run. And I think it was all for the video. Thanks for watching the coding part, and if you watched to the here, I will be really happy if you can like the video and add comments to it. So let's get to the outro. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Data Science Projects where I have more than 20 data science projects with their datasets on that playlist. You can just reach to it from the cards of this video or the link in the description. See you in the next tutorial. Have a great day.